Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem from Laplace Transform. So let's get going. Problem: find Laplace Transform of t sin hat. Let f of t. Just compare this with the formula L of t power n f of t. So here we are going to apply multiplication by powers of t formula because we have t here, right? Sin hat is multiplied by t power 1. That's the thing we have to understand. Okay, so just compare L of sin hat with L of t power n f of t. If you compare these two, we can say that, or we can consider f of t equal to sin hat for our convenience, right? Now let's find L of f of t, that is L of sin hat. Since we know that L of sin hat equal to a by s square minus a square, which is a formula, right? So you'll get a by s square minus a square, right? Which is our f of s, right? L of f of t equal to f of s. Now we'll find L of t into sin hat using multiplication by powers of t. That is, if L of f of t equal to f of s, then L of t power n f of t equal to minus 1 power n into d power n ds power n of L of f of t, or you can write f of s simply. Okay, this is equal to minus 1 power for n equal to 1 because you have 1 to the power t, right? We have t power 1 here, so we'll apply n equal to 1 in the formula. Simply 1 d power n by ds power 1 into L of f of t, that is sin hat, right? And this gives us L of t sin hat equal to minus 1 power 1 is minus 1 into d power 1 by ds power n is d by ds of L of sin hat is a by s square minus a square, or you can write f of s, that is a by s square minus a square. Okay, since a is constant, you can just pull this out. You'll get minus 1 into a into d by ds of 1 by s square minus a square, right? We know that 1 by x can be written as, or x power n, say x power minus n, right? Then x power minus n derivative will be minus n into x power minus n minus 1, right? Likewise, you will find derivative to this. You'll get, you can write minus a directly. Okay, derivative of 1 by s square minus a square is, you can write s square minus a square power minus 1. You can just write this as s square minus a square power minus 1. Now find the derivative of this. We'll get minus 1 into s square minus a square power minus 1, which gives us minus s square minus a square power minus 2 into, here you'll get the inner derivative, that is derivative of s square minus a square, which is 2s. So you'll get 2s here, or I'll just show you clearly. Now you can write this as minus 2s by s square minus a square whole square. Okay, I'll just show you clearly. You can write 1 by s square minus a square. Prime is nothing but derivative, okay, with respect to s. You can write this as s square minus a square inverse, right? Power minus 1. Now find its derivative. Since we know that x power n, derivative of x power n is n into x power n minus 1. Just apply this formula, n into x power n minus 1, which gives us minus of s square minus a square into d by ds of, here we need to find inner derivative, right? Minus 1 gives minus 2 into derivative of s square with respect to s is 2s minus derivative of a square with respect to s is 0. This gives us minus. You can write s square minus a square power minus 2 as s square minus a square whole square into 2s, since x power minus n can be written as 1 by x power n, so that you can write s square minus a square power minus 2 as 1 by s square minus a square whole square. Okay, clear? Now derivative of 1 by s square minus a square is, we know the value, right? I'll just write it down. I'll have minus 2s by s square minus a square whole square. This is equal to minus into minus plus 2s into a 2as by s square minus a square whole square, which is required solution. Therefore, L of t sin hat equal to 2as by s square minus a square whole square. Okay. Well, we have seen a problem from Laplace transform in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.